This is Section 8.1, Part A, Introduction to Vectors. Your I can statements for this section: I can represent and operate with vector geometrically, and I can solve vector problems and resolve vectors into their rectangular components. Many physical quantities, such as speed, can be completely described by a single real number called a scalar. A vector is a quantity that has both magnitude and direction. The velocity of a football is a vector that describes both the speed and the direction of a ball. A vector can be represented geometrically by a directed line segment or arrow diagram that shows both magnitude and direction. The initial point is the starting point of a vector that is represented by a directed line segment, also known as a tail of the vector, and the terminal point is the ending point. So if we look at the vectors on the right, a vector is always going to have an initial point and it's going to have a terminal point. The terminal point is going to be where the arrow is located. Most of the time they're going to show you these on a coordinate plane, so they can also tell you the direction, so what degree it is, and it's going to tell you the magnitude or the length. When we talk about vectors, they can write it as a bold A, or they can write it with an A with a partial arrow over it, or they can use the endpoints and say vector AB. So we need to decide if each of these quantities describes a vector or a scalar quantity. Remember, it's a scalar if it just talks about a specific number. It's a vector if it has a direction and a magnitude. So a boat traveling at 15 miles per hour, this just tells us a speed, so that's just one number. So that is a scalar. A hiker walking 25 paces due west, this gives us a direction. So we have a value and a direction, so that is a vector. A person's weight on a bathroom scale. Weight is actually determined because of gravity, and gravity pushes you downwards. So we're talking about weight and not mass. There is a direction because it is pushing it down. So this is a vector. A vector is in standard position if its initial point is at the origin. The direction is the directed angle between the vector and the horizontal line. Magnitude is the length of your vector. Most of the time they're going to represent this with the absolute value around the name of the vector. Quadrant bearing is a directional measurement between 0 degrees and 90 degrees east or west of the north-south line. And the true bearing is a direction measurement where the angle is measured clockwise from north. So if we look at these, this would be from the horizontal, so that would just be the direction. So we would say 35 degrees with the horizontal. On this one, if we measure clockwise, that's from north, so that would be a true bearing of 145 degrees. If it says west of north, you go towards the west from the north, so like this would be 30 degrees west of north. So using a ruler and a protractor, we need to draw an arrow diagram for each quantity described, include a scale on the diagram. So the first thing we want to do is just make our XY coordinates. Once you have your coordinate plane drawn, you're just going to get out a protractor. Because this one just says it's 30 degrees, we're going to measure that with the horizontal. So we line this up. We're going to go to 30 degrees, and we're going to put a little mark so we know where that's located. Once we have that mark, we're going to come up with our scale. So if we get our ruler, we want to move it so that it starts at the origin and goes through our point. And we need to come up with a scale. We know that we have 20 feet. We cannot measure 20 feet with this ruler. So our scale can be that 1 centimeter is equal to 1 foot. Now on my board I can do that and it's going to fit. On yours it's going to have to be a different scale so that it fits on your paper. Now 1 goes into 20 times. So if we measure out 20 centimeters, we're going to here. Then you draw your arrow. You need to indicate what your angle is, and you need to make sure you have your scale on your drawing. This time it says we're going south 60 degrees west. So from the south, you need to go 60 degrees towards the west. We're still going to start by making our coordinate plane first. Now on the problems that say west of south or north or west of north, it's always going to be vertical. And then you have to decide if your protractor is going to be facing to the left or to the right, depending on if they say west or east. So if we start at the south and we go 60 degrees towards the west, and then we put our little mark, then we can get rid of our protractor. Again, you have to come up with a scale. So we're going to get our ruler. We're going to line up the ruler so that 0 is at the origin. We line up our ruler with our mark. And again, we have to come up with a scale. So this time, let's say 1 centimeter is equal to 2 miles per hour. Since our measurement should be 30 miles per hour, 30 divided by 2 gives us 15. So we need to measure out 15 centimeters. This would be our vector, and we do need to mark our angle. Vectors can be parallel if they have the same or opposite direction, so if the vectors have the same slope. For vectors to be equivalent, they have to have the same direction and the same magnitudes. They have to have the same slope and they have to have the same length. Opposite vectors are going to have the same length, but they're going to be in opposite directions, so they're going to be pointing different directions. So example of parallel vectors would be vectors A, C, E, and F. Equivalent vectors would be A and C because of the same length and pointing the same direction. And opposite vectors would be A and E or C and E. A resultant is one vector that is the sum of 2 or more vectors. We're going to end up with a 0 vector if the resultant ends up being 0. We can get this, it's also called the null vector, or it's written with a bold 0, or it can be written as 0 with the symbol for a vector over top of it. Now one way to find a resultant vector is to use the triangle method. And to do this, you're going to take vector B and you're going to translate it so that the tail of B starts at the tip of A. So we shift it over so that B starts where A ends. Then to draw your resultant, you just start from the beginning of A and draw it to the end of B, and that would be your resultant vector. In an orienteering competition, Tia walks north 50 degrees east for 120 feet and then walks 80 feet due west. How far and at what quadrant bearing is Tia from her starting position? So we're going to start by drawing our coordinate plane first. Now we know she's going 50 degrees east of north. So if we start at north and we go 50 degrees towards the east and we put our little mark, that marks where she's headed. Now we need to use a ruler to create our scale. Now we want to come up with a scale that will work for both measurements. Since we have an 80 feet and 120 feet, we want to come up with something that divides into both. So 40 divides evenly into both of those values. So I'm going to say 1 centimeter is equal to 40 feet, or 10 centimeters, sorry. For my case, I'm going to do 10 centimeters is equal to 40 feet, or 1 centimeter is equal to 4 feet. 4 goes into 120 30 times, so I need to measure out to 30 centimeters. Again, your scale is going to have to be different so it can fit on your paper. Now, where the first vector ends is where the second vector is going to start. And it says from there, she's going to walk due east 80 feet. So if we line it up, we're going to start at the end of vector A, and we want to go east 80 feet. 4 goes into 80 20 times. So we'll start here. We'll go over to 20 centimeters. This will be the end of our second vector, or vector B. Our resultant vector starts at the beginning of A and goes to the end of vector B. Now this measurement is around 46 centimeters. We know that every 1 centimeter is equal to 4 feet on our scale. So we want to see how many feet that would be. And if you cross multiply and divide, we're going to get this is equivalent to approximately 184 feet. We also need to measure the angle. So if we get our protractor back out and we measure from the north again, this is about 66, 65, 66 degrees east of north. So her bearing, when she's done from the starting point to the ending point, she's going to be 184 feet away, and she's going to have traveled 66 degrees east of north.